Have you ever pondered the origins of the universe? What was there before everything? These questions have sparked curiosity in human minds for ages, leading to a plethora of theories and beliefs. From ancient cosmologies woven into myth and religion to modern scientific theories, the inception of the universe has always been a subject of intense debate and fascination. But today, we're not diving into mythology or philosophy. No, today we're going scientific, peering back in time all the way to the very beginning. So strap in as we dive deep into the scientific explanation, starting from the Big Bang. The Big Bang, a phenomenal cosmic event that gave birth to our universe around 13.8 billion years ago. A time when all matter, energy, space, and even time itself was condensed into a single point of infinite density. A singularity, an entity so compact and intense, it's beyond our current comprehension. But this wasn't a typical explosion. It wasn't an eruption into space, but rather an expansion of space itself. In an incredibly tiny fraction of a second, the universe ballooned from a subatomic speck to an entity of astronomical size. This event, known as cosmic inflation, set the stage for everything that follows. In the aftermath of this rapid expansion, the universe was a hot, dense sea of particles. As it continued to grow, it cooled and particles began to combine, forming the first atoms. This period, known as the recombination, occurred about 370,000 years after the Big Bang. So, how do we know all this? Well, we have evidence, the most compelling of which is the cosmic microwave background radiation, or CMBR. This is the afterglow of the Big Bang, a kind of echo from the early universe. It was first detected accidentally in the mid-20th century and has been studied extensively ever since. The CMBR is remarkably uniform, but it does have tiny temperature variations. These minute differences correspond to areas of slightly different densities in the early universe, areas that would eventually evolve into galaxies and large-scale structures. It's a story that's both mind-boggling and awe-inspiring. A single explosive event that set the stage for galaxies, stars, planets, and life itself to emerge. From this violent explosion, the universe as we know it began to take shape. In the immediate aftermath of the Big Bang, the universe was a hot, dense soup of particles. Imagine it, a swirling, chaotic mix of protons, neutrons, and electrons, all moving at incredible speeds. This was a time of pure energy, where the concept of matter as we know it didn't even exist yet. As the universe expanded, something remarkable happened. The soup of particles began to cool. This cooling allowed protons and neutrons to come together to form the nucleus of the first atom, a single proton nucleus that would become hydrogen. This process, known as nucleosynthesis, was the birth of matter as we know it. But the universe wasn't done yet. As it continued to cool and expand, these hydrogen atoms began to combine with each other under the force of gravity. They formed helium atoms, the second simplest atom after hydrogen. You see, this period was a pivotal moment in the history of the universe. The formation of these atoms set the stage for the creation of more complex elements, the building blocks of stars, planets, and eventually life itself. It's fascinating to think about, isn't it? In the intense heat and density of the early universe, the simplest atoms were formed, and from this humble beginning, the complexity we see in the universe today began to take shape. So in a way, we can trace our origins, the origins of everything we see around us, back to those first hydrogen and helium atoms. They were the seeds from which the vast cosmic garden grew. With the formation of these atoms, the universe took its first step towards complexity. The universe was not always a cosmic sea of stars and galaxies, so how did they come into existence? Imagine a vast, infinite expanse of space, filled with nothing but hydrogen and helium atoms, the first children of the Big Bang. Now picture these atoms, drawn together by the invisible hands of gravity, starting to clump together. This is the beginning of the birth of stars. As more and more atoms join the gathering, the mass of the clump increases, and so does the pull of gravity. The atoms, now packed tightly, begin to vibrate, colliding with each other, generating heat. This heat is so intense that the atoms start to fuse together, a process known as nuclear fusion. As hydrogen atoms fuse to form helium, they release energy in the form of light and heat. Thus, a star is born, a radiant beacon in the dark expanse of the universe. But what about galaxies? Well, galaxies are like cosmic cities full of stars. As stars form, they don't do so randomly. They're drawn to each other, forming clusters. These clusters of stars, bound together by gravity, are what we call galaxies. Now, to visualize this process, we turn to the James Webb Space Telescope, a marvel of modern technology. With its ability to peer back in time, it has captured images of the earliest galaxies, dating back to between 370 million and 650 million years after the Big Bang. These images reveal galaxies not as pinpricks of light, but as extended objects with visible structure. These galaxies show strong emission line signatures indicating intense recent star formation. These galaxies, brimming with stars, became the building blocks of the universe. The birth of stars and galaxies is not just a story of cosmic creation, but a testament to the power of gravity, the transformative energy of heat, and the unending dance of atoms in the universe. It's a story that continues to unfold, with each new image from the James Webb Space Telescope adding a new chapter, a new revelation about our cosmic origins. From a singular point to a vast, complex cosmos, the journey of the universe is truly awe-inspiring. Today we find ourselves in an expansive universe that's home to a multitude of celestial bodies, each with its own unique tale. The universe is a grand tapestry woven with galaxies. Among these galaxies, our own Milky Way holds a special place. It's just one of the estimated 2 trillion galaxies that grace the cosmos, each a bustling hub of stars, planets, and other celestial entities. Recently, the James Webb Space Telescope has given us a detailed view of 45,000 galaxies, revealing fascinating insights into their structures. Galaxies are the cosmic neighborhoods of stars. These fiery balls of gas are the universe's primary source of light and heat. Their life cycle, from birth to death, punctuates the cosmic narrative with periods of creation and destruction. Stars are not just celestial bodies, they are the cosmic forges where elements heavier than helium are formed. Now let's talk about planets. These celestial bodies orbit around stars in elliptical paths. They come in all shapes and sizes, from gas giants like Jupiter to rocky worlds like our Earth. The James Webb Space Telescope recently confirmed the existence of an exoplanet, LHS 475b, almost the same size as Earth, located 41 light-years away. These discoveries remind us that we are part of a broader cosmic family. Black holes, the universe's most mysterious residents, are regions of space where gravity is so strong that nothing, not even light, can escape. They play a crucial role in the evolution of galaxies and are a testament to the extremes that nature can reach. Dark matter and dark energy are the elusive components of the universe. They don't interact with light, making them invisible and detectable only through their gravitational effects. Together they make up approximately 95% of the universe, guiding its expansion and shaping its structure. And what about the future? Well, the universe continues to expand, driven by the enigmatic force of dark energy. As for its ultimate fate, a big freeze, a big rip, a big crunch, or a big bounce, only time will tell. The universe's story is a testament to the power of time, physics, and a whole lot of cosmic dust. From the Big Bang to the formation of galaxies, we have journeyed through the early epochs of our universe. We've taken a cosmic voyage back in time, from the explosive birth of our universe in a cataclysmic event aptly named the Big Bang, navigating through the sea of elementary particles to the formation of the first atoms. We've seen how these atoms, primarily hydrogen and helium, eventually came together under the influence of gravity to form the first stars. These stars clustered together, forming galaxies, the building blocks of our universe. We've also touched upon the current state of our universe, exploring some of the latest revelations from the James Webb Space Telescope, our eyes into the distant past. We've peered into the Great Observatory's Origins Deep Survey, a region where astronomers study the earliest stages of the universe, revealing some of the earliest galaxies. We've seen how the James Webb Space Telescope has discovered about 700 new galaxies in this region, dating back to between 370 million and 650 million years after the Big Bang. We've also explored the discovery of the exoplanet LHS 475b, a world almost the size of Earth, located 41 light-years away. This discovery was made possible by the James Webb Space Telescope's unprecedented sensitivity, which allowed it to detect the dips in starlight as the planet passed in front of its host star. We've also acknowledged the challenges and errors that come with pushing the boundaries of our scientific understanding. Indeed, some of the initial claims about distant galaxies may need revision due to calibration issues with the telescope. Yet these are the growing pains of any new scientific endeavor, and they do not detract from the awe-inspiring images and revelations that the James Webb Space Telescope has provided us. Remember, our understanding of the universe is ever-evolving, much like the universe itself. So, if you enjoyed this cosmic journey, don't forget to like, comment, and share this video. Stay curious, stay astounded.